here is our talk. It's about how to implement your online search quality evaluation with Kibana. So with Ilaria, we implemented this tool for a client, and we are going to illustrate you how to create all the evaluation tools with Kibana. And I'm starting presenting me, and then I leave to Ilaria the word. So I'm Anna. I'm born in Padova, and I'm a R&D search software engineer in Sease. I joined Sease almost 3 years ago. I have a master in computer science, and currently I'm also part of the artifact evaluation committee of the SIGIR conference. I am a Solr Elasticsearch open source expert, so I do consulting on this topic. I also deal with recommender systems, machine learning, and ranking system evaluation, so on. And apart from the work, I'm also an organist, a Latin music dancer, and orchid lover. So I pass to Ilaria.
Okay, good evening, everybody. It's a pleasure for having me here. My name is Ilaria. I was born in Tarquinia, an ancient Etruscan city in the center of Italy, but I live abroad in Qatar. And I've been working as information retrieval machine learning engineer at Sease for about 2 years. I earned a master in data science in 2020, and I have passion for data mining and machine learning techniques, and mainly deal with their integration with search engine and information retrieval system. And I'm a sport lover, and I was a professional basketball player some years ago. So this is the agenda of the talk today. First of all, we will introduce the online search quality evaluation. Then we will just briefly talk about the A/B testing. We'll then dive into our Kibana implementation, so the reason behind it, and we will explore what are the tools that Kibana provide. After that, we will show you through practical example how you can create visualization and dashboard in Kibana to compare different models. And finally, we will highlight Kibana pros and cons. So let's get started with online evaluation. Yeah, what is online evaluation? Online evaluation is one of the most common approaches to measure the effectiveness of an information retrieval system, and it remained the optimal way to prove how your system performs in a real-world scenario. So it gives you the necessary information to evaluate, improve, and understand the model behavior. Both offline and online evaluation are vital for a business, so one does not exclude the other. You should monitor both the aspects, and it is important to start with a good offline evaluation first before going into an online one. Offline evaluation is one of the most common approach that help you to find the most promising model before the deployment, and it has some advantages like find anomalies in data. Then you can set up a control environment not influenced by the external world. Then you can check how the model performs without impacting the production system. So you can make improvement, you can fix bugs, tune parameters, etc. And it is fast and cheap than the other. Of course, you can rely on offline evaluation, checking the performance of your model through the analysis of offline metrics, but you cannot be you cannot be sure what will be the impact of the model online. So in your search engine, in fact, the final word of a success or a failure of the final release is decided online, when you can where you can measure the vital metrics for your business. So you can measure profit, improvement, regression with real users. You can also identify anomalies for unexpected query, anomalies in user behavior. Of course, it is more expensive in terms of time and cost. Why is important? It's important because there are several problems that are to be detected with an offline evaluation. The first aspect is that you can have an incorrect relevant judgment set that allow us to obtain model evaluation results that aren't reflecting the real model improvement or regression. Some examples are when you have just only one sample per query group, when you have only one relevance label for all the sample of a query group, or is important the interaction that you consider for the creation of the dataset, because ideally you should create two sets that follow the same probability distributions in terms of query and relevance label. And finally, you may have an evaluation set that can be too small, so not representative of the data. The second aspect is finding a direct correlation between the offline evaluation metrics and the key performance indicator used online, because it's not obvious, neither simple to understand how an improvement in offline metrics will reflect in terms of click, sales, and revenues. The final aspect is that offline evaluation is based on implicit and explicit relevance label that are not there, that not always reflect the real user need. So now we will move to A/B testing part. So if you want to compare different models online, there are two types of online testing that are widely used in the industry: A/B testing and intermediate. Of course, with this for this talk, we will focus on A/B testing because it's the one that we use, but we want just to highlight the main difference between them. So A/B testing, in general, you will compare two models, and the population is divided into groups. It is the most popular approach, also because it's easier to implement. While with interleaving, users are shown both variants of both models by interleaving the result. These tests require a smaller amount of traffic and time. It's less influenced by the user variance because, of course, the population is not divided in groups, and so all the users are exposed to all the models that you are compared. It is more sensitive to differences between models, and it prevents users to be exposed to a bad system for the entire duration of the experiment. Here, with this picture, I just want to show you how you may divide the population into groups for the A/B testing. So in general, you can do 50-50, and you have a group exposed to the model A, for example, the control model, and then a group exposed to the model B, the variation group. One important aspect that you have to consider in the A/B testing is the noise, because most of the time we ended up with clients that only consider the total amount of sales, total amount of click, or whatever happened in their site, in their search engine, without considering only interactions coming from result page ranked by the model that they are comparing. Like in this example, here we are evaluating two models, model A and model B. We can see that model A got 10 sales from the home page and 5 sales from the search page. Model B got 4 sales from the home page and 10 sales from the search page. You may think that model A is better than model B because in total, model A got more sales than the other. But effectively, it's not like this because model B got double sales from the search page. In fact, it's important to evaluate, to compare the models on the pages where the model is actually acting. So don't consider, for example, click or sales coming from other pages or coming from other sources, for example, coming from Google. You don't have to consider this. And our recommendation is to remove this noise or reduce it as much as possible. Here, there are some metrics that you can measure online. Of course, the most common and the most important one is the click-through rate, because as you may imagine, is the first kind of interactions that a user have with your search engine. So it's something that you want to monitor and improve, because you hope that that users will interact with the search results. So they will click on items, download songs, for example, or add to favorite some hotels. Then also another aspect to monitor is our sales or revenue rates, because maybe you got an incredibly click-through rate, but you never sell a single thing and you have an e-commerce, so maybe the search engine is not working as you expect. Another important metric to monitor is the time spent on a search result after the click. So for example, if a user click on a document, if he spent a lot of time reading that document, it means that it's relevant for that query. And finally, you may want to monitor the amount of query reformulation. So how many times a user rewrite the same query, and also the bounce rate. So how many times a user click on an item and then go back to the result, click on an item and go back to the result, and so on, because this signal reflects a low relevance in general. Our recommendation is try to start with signal as close as possible to your search engine, and then monitor all of them step by step. Here, I just want to give you some observation about experiment design. So generally in real world, you deploy models in different platforms, desktop, mobile, and tablet. So you should test different model on each device independently. How long to test? You can stop your test once the statistical significance is higher enough, but generally not less than 2 weeks. And you can decide to compare from 2 to many models, but of course, it depends also of the amount of available traffic. The more the system you compare, the harder the process to detect a winner. So in general, it is recommended to keep it as simple as possible. Now let's dive into our Kibana implementation. The main factor behind it were that, of course, nowadays available offline evaluation software presents some limitations in terms of metrics and data to use. And for example, it is difficult to find and therefore to use the same metrics that you use to optimize the model. So use the same metrics in both offline and online evaluation. And it's not easy and immediate to remove external factor or corrupt interactions that you don't want to consider in your analysis. That's why we decided to implement this approach through the use of Kibana. Kibana is an open source software. Open source is open to discussion due to the Elastic license that provide search and visualization capability for index data and Elasticsearch, allowing you to explore and visualize a large volume of data. What are the configuration steps? So you should create, or maybe you have it already, an active Elasticsearch instance associated with Kibana. Then you should create an index. You should index user interaction data that you have collected, that you will need to evaluate the model on the chosen metrics. Then you have to create a data view, because Kibana requires this data view to access Elasticsearch data and explore them. And finally, you can create visualization and dashboard to compare models. It's important to collect the user interaction. So this is necessary to understand how the users are interacting with your search engine. So in our case, the most important features were, of course, the test group to identify model assigned to a user group, then the query, also the timestamp, if you want to make a temporal analysis, interaction type, to know what are the interactions that took place. And about this one, we also added 4 additional single features, so impression, click, add to cart, and sales, that are just supporting calculation to create some visualization, some graphs. They are Boolean field, and they have 0 or 1, depend on the interaction type. Then we have the document ID, in our case, a book ID, if you want to make an analysis on a specific product. Query result count, so if you want, for example, make an analysis based on the number of result count returned by a query, and then you can consider and add additional features that you may consider useful for your case and your domain. Now I'll just briefly introduce some of the Kibana tool, the one that we mostly use. The Discover tool, that is the starting point to explore data. Visualize, it has the ability to create different kind of visualizations, line, bar, pie, table, etc. Or you can create custom panel with special editors like time series, visual builder, and Vega. Then we have the dashboard part, where you can combine different visualization together into dashboard to have a visual and an immediate comparison of the models. There is also the alerting tool to monitor data in real time and create custom alert triggers. You can also set up a destination to receive the notification when the alert is triggered. And finally, the management tool that it has the ability to manage indices and adjust Kibana runtimes configuration. Now, in this first slide, I will just do a high-level introductions of the panel type that we use for this implementation, but in a few minutes, Anna will show all of them in detail. So the first one is the data table, as you can see from the screen. So it shows data in tabular form. You can calculate predefined metrics and represent as table column, in this case, sum of impressions, sum of clicks, sum of add to cart. Or you can split row based on terms aggregation, in our case, using the field test group. And you can also do some sub-aggregation, in our case, using the field timestamp per day. Then here is a data table as well, but it is we created using the editor's time series visualize builder. So the main difference between the previous one is that with this editor you can calculate custom metrics. So with this one we were able to calculate the click-to rate and the add-to-cart rate. Then we have this graph. So as you can see, it shows data in vertical bar form. So you can calculate predefined metrics and represent it in the y-axis. And you can compute metrics on aggregated data, and obtain buckets will be represented in the x-axis. And finally, we have the Vega panel type that is programming languages that allow you to create custom visualization. You can make Elasticsearch query and manipulate the response, the query response, in a high customized format. Now I'll pass the ball to my colleague Anna for the visualization example.
Okay, thank you. Yeah, so now we are going to look at how to implement all these visualization we use for the evaluation of the model. So the first one is a table we create with the time serial visual builder. And here we represent the performance of the two models we are comparing, so model A and model B. And in particular, we create several columns representing the most important metrics we would like to look at. So starting from the total number of impression, clicks, and add to cart we obtain. For example, in this case, we supposed to be an e-commerce of books. And then the two most important metrics that are the click-to rate and the add to cart rate, that are the ones we are interested in because they are also the ones we use for the optimization of the two models. And here we have one model for each row, and we can easily compare the performance looking at the table. And so this is why it's useful. And it's also useful to identify some bugs that can happen in the online testing setup, because it happens that a wrong model name was given from the front end, and then we were able to see it as a new row in the table and then fix the problem. So starting from the columns, so how to implement them. There is this columns tab in the user interface where you can set up first the rows. So here we have seen that we have the model name as row. So we group by the test group, and we put a threshold of 3 in the rows field. In this case, we are just comparing two models, so we are going to see both of them. You can clearly fix the threshold looking at the number of models you are comparing. Then the columns, so the total impression is the name we give to the total number of impressions for each model. And here we computed with a sum aggregation on the impression field that, as mentioned by Ilaria, is containing Boolean values. So 0 if it is not an impression, and 1 if it is an impression. So summing together all the ones, we have the total number of impressions. The same for the clicks and add to cart. So again, a sum aggregation of the corresponding fields. And then the most complex metric, the click-through rate. So we define the formula of the click-through rate as the division between the total number of clicks and the total number of impressions. So in order to compute it, we first make again the aggregation on the field impression, the sum aggregation. The same for the field click. And then thanks to the bucket script, we were able to implement the formula. So specifying the variable's name and calling them as params.clicks and params.impression in the painless script. The same for the add to cart. So here the formula is the total number of add to cart divided by the total number of clicks. And again, the same process. So the sum on the click, on the to cart, and then the division in the script. Here, we create a visualization to compare only desktop model. So we filter all the interactions in the panel options tab using the panel filter. So we decide to look at the interaction, only the interaction with the desktop device. And the nice thing is that you can create another visualization for the, for example, mobile device, and then put them together in the dashboard. So here we can put side by side the two visualizations, and it makes easier to compare the different devices, the different models, and make an evaluation. Then another table is regarding the single product evaluation. This table has the same columns and rows as the one before. The only difference here is that we are looking just at one product. In this case, since we are talking about books, we are filtering about on the book ID, and then we look only at the interaction of that specific product. And this could be interesting to see how the model performs, I don't know, on a bestseller product, a new product that is added in the e-commerce, a sponsored one, and so on. So the only difference in the settings is in the panel filter. So here, instead of the device, we put the ID of the book. Another time series visual builder table is the one where we compare the top queries for a specific model. So here you're going to see one row for each query selected category, that in our case is also the query ID, the query we are looking at. And then for each query, we compute the total number of impressions, click add to cart, the click-through rate, add to cart rate. And then we add another column that is the frequency, that is the total number of interactions that that query collected. And here we can see which are the queries with which the user interact the most. And here the table is just for model A. Again, you can create another visualization with the other model, or just remove the filter and make an overview of general evaluation for for each query. So the difference here is in the row. So we group by the query selected category and select the first 5 rows, since we are looking at the top 5 queries. Then the frequency column, that is just a value count aggregation on the category. So we are computing the number of interactions for each category. As mentioned before, we are doing this for the model A. Again, you can decide to do this for the other model or not, or to keep both together. Then the vertical bar. So we exploit this type of visualization to look at the query count distribution for each model. So here we represent in the y-axis the sum of impressions, so it is indeed the total number of impressions. And then in the x-axis, the category. So the total number of impressions for each category ID you will see in the x-axis. And this is useful to look at how impressions are distributed among queries, so categories, and for a specific model. So it helps us identify which are the queries that are most used by users. And also it helps us in creating some ranges that put together similar queries, in also looking at the interactions, and create different visualization depending on this group of queries. So here we can define in the data tab the y-axis and the x-axis. So in the y-axis, as mentioned, we put the total number of impressions, and the x1 we made a terms aggregation by category and ordered by the total number of impressions as a descending order. Then this is again a data table, but it's different from the previous one because it is not a time series visual builder table. So here we couldn't compute the metrics we have seen before, like the click-to rate and add-to-cart rate, since they need a specific formula to be implemented. But you can just do some simplest aggregation, like the sum aggregation or the count. And here we use it to look at the types of interactions for each model and also for each day. So we can look here how many impressions, how many clicks, how many add to cart we collected for each day and for each model. So it can help us identify some imbalances in the setup of the online testing, for example. So we can see that a model is collecting a lot of more impression with respect to the other, or also this is something that really is happening. So you can analyze it and understand why and so on. So here the columns are similar as the one before, with the addition of the count aggregation, so the total number of interaction per model and per day. And the interesting part is on the row. So here again we divided by the model name, so terms aggregation on the test group. And then we again split the row by the date, so looking at the different day for each model. Then the most complex visualization type we use in Kibana is the Vega implementation. So here you can define your code, you can define this explicit query you're going to put to Elasticsearch, and how to manage the results and how to plot the results. So here we create again a vertical bar with the Vega, and we analyze the add to cart rate for each query, looking only at those queries that collected a number of impressions that is less or equal 180. So we can evaluate how the model performs on different ranges in the search domain curve. So we expect less queries with a lot of interaction and more queries with less interaction. So we can divide by ranges the number of impression or total number of interaction, and then look only at each range and analyze it. So maybe looking at this type of visualization, you can see that your model is going well on the most frequent queries and less well on the less frequent queries, and decide to use two different models, for example, or other considerations. So here is the Vega code. So the first one is the Elasticsearch query. So here again, we made a terms aggregation on the query selected categories, so we can divide the x-axis by category ID. Then we computed the other aggregation for the add to cart rate formula, so the total number of impression, click, and add to cart. And we implemented the add to cart rate. We also made a further filter with the bucket selector. And as mentioned before, we are looking only at queries with less than 180 impressions. So here we are using the total number of impressions and put a threshold on it using the parse.impression count less or equal 180. In our scenario, we are also supposing to always have a number of clicks that is greater than the number of add to carts. So we are supposing that user need to click on a product in order to add it to the cart. So we are also removing all the interaction that do not respect these conditions. So if the click is less than add to cart, we remove interactions and the query. So then there's some visual part. So again, you can define the type of plot you are going to represent. Here is the bar plot. You define the X and the Y axis, so the query ID for the X and the add to cart rate. You can also add those elements in red and blue you see at the center of the top of the plot. So we add the mean add to cart rate among all the queries in the range, so this red bar, and then also the value, because here it's easy because you only have 6 queries, but if you have hundreds of queries, you can easily look at the average value for the add to cart. And also in blue, you can directly write the number of queries you have in the visualization. Another useful thing you can do for the evaluation of the model is comparing them on the same queries, because it can happen that some user make some queries in the model A, for example, and not in the model B. So to compare them on the same baseline, you would like to look at which are the queries that are done in both models and then just consider those queries. So first of all, you need to extract the list of unique query IDs for each model, then find the common queries, and finally use them in the Kibana visualization to filter interactions. So the first step is the Elasticsearch query. Here again, we would like to have the list of query IDs, so we do a terms aggregation of the selected category, and then we filter by the model. So we would like to execute this query both for model A and for model B. This is the example for the model B. And another thing we do is consider the query result count. Query result count is a field that represents the number of results that are returned for a query, for each query. So for example, here we would like to see the query IDs just for those queries that have a number of results that is less than 10. And in the right, you see the results of the Elasticsearch query. So we have the category ID as the key. And these are the first 5 queries, for example, for the model B. This is the Python script. I'm not going in details on this, but it's just merging a join operation between the 2 lists from model A and B. And we are also creating directly the Elasticsearch query we need to integrate into the Kibana visualization to filter interactions. So again, if you have many queries, it's useful because in an automatic way, you can have the Elasticsearch query to integrate in Kibana. And so this is an example of the query you're going to see. So you're going to select the specific query IDs that you find to be the common queries between the 2 models. So here we add these filters. So at the top of the visualization, you can add a filter and just copy and paste the Elasticsearch query you have already seen. And then also the filter on the query result count. So as mentioned before, we would like to see only the queries with less than 10 results in the list. Here, this visualization is useful to evaluate how the model performs on a specific type of queries. So you can put them together and just make an average, for example, add to cart rate to look at the model performance. And we also use it to see how it performs on a small list of results and a big list of results, because we will expect to see that with few results, the models are not changing too much in terms of performances. Because if the user can see all the products together for example, in a web page, even if they are in different orders, we do not expect the user experience to change too much, while in bigger lists, the ranking could impact more on the user experience. And here is the Vega code. So again, the query to select the data we plot on the vertical bar. So the category for the x-axis and the add to cart rate for the y-axis. Here is an example of the dashboard. Here we put together the visualization for the different ranges on the query results. So for example, in the first column, we have the query ID and the average add to cart rate for all the queries with less than 10 results. And in the first row, this is for the model A, while in the second row, this is for the model B. So you can easily compare how model A performs on query with less results and the model B, and then look also at the other ranges. So for example, on huge list, you can look at the column at the right and look at the add to cart rate you obtain for both the model and compare them. Okay, I leave Ilaria for the conclusion.
Yes, let's conclude the talk with Kibana pros and cons. So as pros, Kibana provides an easy and intuitive graphical user interface to use, and it has the ability to create detailed reporting dashboard, and as shown before. You can filter unwanted data. So if you want to remove from the analysis, for example, corrupt interactions or interactions coming from tests or coming from unwanted sources. If you index new data, visualization and dashboard are automatically updated. And then you can export and also import visualization and dashboard using the export object API. So if you want to reproduce this evaluation for a future project, is very easy. As cons, some features in Kibana are still not available. There are some limitations for aggregated data, especially for more complex query. Then we have some Vega limitation, let's say, we just want to say that Vega is a very powerful tool, but it's not so easy and immediate to use. And finally, if you have to, for example, if you want to test a new model, so the model name changes, or if for some reason you have to rename the data view that you previously built, you have to manually edit the filter in all the visualization in Kibana, unless you can also create other visualization. But if you want to use the visualization that you have already created, you have to manually change the filter. Okay, here are just some references. So you can find the link to our blog post about search quality evaluation, both offline and online. Keep an eye on our blog page. And thank you very much for your attention. If you have any questions, we are here.